Bismillahirrahmanirrahim. Assalamu alaikum students. The topic of today lecture is inverse Laplace transformation of derivatives, and this is our lecture number 28. Let us start our lecture. Here we see how we can apply the Laplace transformation on initial value problems. Last time we developed some kinds of formulas in which we see first derivative Laplace, the formula of first derivative Laplace, then second derivative Laplace, and third derivative Laplace, and then I write the general form of the Laplace the general form of nth derivative in Laplace transformation. Here the following procedure we shall adopt for solution of initial value problems. Number 1, take the Laplace transformation of both sides of the given differential equation. Number 2, use the initial condition to obtain an algebraic equation and then solve this equation for the Laplace transformation of the required solution. Third one is take the inverse Laplace transformation to get the required solution. Here we take an example of initial value problem, that is y double prime plus y is equal to 0, then y of 0 is equal to 1, and then when y prime of 0 is equal to minus 1. First of all, we take the given differential equation, that is y double prime plus y is equal to 0. Say this is equation number 1. The first step is take the Laplace transformation on both sides. We get, here we apply, as you see, here we apply the Laplace on left side and on right side. Laplace of y double prime plus Laplace of y is equal to Laplace of 0. And you know that Laplace of y double prime is equal to s square capital Y of s. This capital Y of s represent the transformation of small y into capital Y and t into s. So s square y capital Y of s minus s y of 0 minus y prime of 0 plus y of s capital Y of s is equal to 0. Here you see that y capital Y of s is equal to 0, and say this is equation number 2. The second condition is use the initial conditions. The initial conditions which are given in the question is y of 0 is equal to 1 and y prime of 0 is equal to minus 1. So I substitute the respective values in equation number 2. So you see here s square y capital Y of s minus s into, and the value of y of 0 is equal to 1. Here you see I substitute here 1. Then y prime of 0 is equal to minus 1, so I substitute here minus 1 plus capital Y of s is equal to 0. S square capital Y of s minus s plus 1 plus capital Y of s is equal to 0. Here you see that I take capital Y of s is common in these two terms and write it as s square plus 1 into capital Y of s is equal to n. The remaining terms I take towards right side. Now y capital Y of s is equal to s minus 1, and this term s square plus 1 is divided on the right side, that is s square plus 1, and now I am able to write it as in this form s over s square plus 1 minus 1 over s square plus 1. The third step is take inverse Laplace transformation of this result. Laplace inverse transformation of this result. You see here I am taking inverse Laplace transformation on both sides. Inverse Laplace of capital Y of s is equal to inverse s over s square plus 1 minus Laplace inverse of 1 over s square plus 1. And you know very well that what is the formula of, this is the formula of, that is the formula of cos t. This is the formula of cos t, and this is the formula of sin t. So I am writing here y of t is equal to small y of t is equal to cos of t minus sin of t. This is our required answer. Now we see second example. Solve the initial value problem. Y double prime minus 9y is equal to minus 8 e raised to the power t, and the initial conditions are y of 0 is equal to 0 and y prime of 0 is equal to 10. Now we start our solution. The given differential equation is y double prime minus 9y is equal to minus 8 e raised to the power t, and say this is equation number 1. Now what is the first step that we have to perform here? First step is to take the Laplace transformation on both sides of equation number 1. So you see here Laplace of y double prime minus Laplace of 9y is equal to Laplace of minus 8 e raised to the power t, and you know that the Laplace of y double prime is equal to s square capital Y of s minus s into y of 0 minus y prime of 0, then minus 9, and the Laplace of y is capital Y of s is equal to minus 8, and you know that the Laplace of e raised to the power t is equal to 1 over s minus 1. Say this is equation number 2. Now we use the second step. In second step we use the initial conditions. The initial conditions are y of 0 is equal to 0 and y prime of 0 is equal to 10. We substitute y of 0 is equal to 0 and y prime of 0 is equal to 10 in equation number 2. So you see here I am substituting at this place the value of y of 0, that is 0, and y prime of 0 is equal to 10. S square capital Y of s minus s into 0 minus 10 minus 9 y of s is equal to minus 8 over s minus 1. When I simplify this and collect the common terms, then I see that s square minus 9 into capital Y of s minus 10 is equal to minus 8 over s minus 1. Okay. Now I take this negative 10 towards right, so it is equal to s square minus 9 into capital Y of s is equal to 10 minus 8 over s minus 1. Now I simplify this. It is equal to 10s minus 18 over s minus 1. Now I divide this term s square minus 9 towards right. So it is equal to capital Y of s is equal to 10s minus 18 over s plus 3 into s minus 3 into s minus 1. Say this is equation number 3. Now what we have to do here, we have to solve this right hand side of equation number 3 by using partial fraction. So let 10s minus 18 over s plus 3 s minus 3 into s minus 1 is equal to a over s plus 3 plus b over s minus 3 plus c over s minus 4, s minus 1. Say this is equation number 4. And then we individually find the value of the unknowns, this a, b and c. So a is equal to 10s minus 18 over s minus 3 into s minus 1, and we check it at s is equal to minus 3. When we simplify this expression at this s is equal to minus 3, so the required answer is minus 48 over 24 is equal to minus 2. Similarly, we find the value of b in this way, 10s minus 18 over s plus 3 into s minus 1, and check this expression at s is equal to 3. When we check this expression at this value of s, we get 30 minus 18 over 6 into 2. This is equal to 12 over 12 is equal to 1. Now we see the value of c, that is equal to we find the value of c in this way, 10s minus 18 over s plus 3 into s minus 3, and check this expression value at s is equal to 1. When we simplify this expression at this s is equal to 1 value, we get 10 minus 18 over 4 into minus 2 is equal to minus 8 over minus 8 is equal to 1. So in this way we find all the values of our constants. So I substitute here 10s minus 18 over s plus 3 into s minus 3 into s minus 1 is equal to, substitute the values of a, b and c, we get minus 2 over s plus 3 plus 1 over s minus 3 plus 1 over s minus 1. And you know that this expression is equal to, as you see here, this expression is equal to y of s. So I am writing here y of s is equal to minus 2 over s plus 3 plus 1 over s minus 3 plus 1 over s minus 1, and say this is equation number 5. What is the last step that we have to perform here? That is that we have to take the Laplace inverse transformation. Inverse Laplace transformation in equation number 5. I'm writing here taking the inverse Laplace of 5 on both sides. So Laplace inverse capital Y of s is equal to minus 2 Laplace inverse of y over s plus 3 plus Laplace inverse of 1 over s minus 3 plus Laplace inverse of 1 over s minus 1. And you know that all these expressions are for the exponential functions, so it is written as minus 2 e raised to the power minus 3t plus e raised to the power 3t plus e raised to the power t. And these expressions I solved before this in our previous lecture, and give a detailed explanation in previous lecture how we can convert the functions by taking Laplace inverse. And you see that how it is easily solvable these questions by using the Laplace transformation. Okay, now I start another example, that is y double prime plus y is equal to 3 cos 2t, and the value of y at 0 is equal to 0 and y prime of 0 is equal to 0. Let's start here. Given differential equation is y double prime plus y is equal to 3 cos 2t. Say this is equation number 1. The first step is take the Laplace transform on both sides of equation number 1. So I am writing here Laplace of y double prime plus Laplace of y is equal to Laplace of 3 cos 2t. Here y double prime is equal to s square y of s minus s capital Y of s minus s y of 0 minus y prime of 0 is equal to plus capital Y of s is equal to 3, and the Laplace of cos 2t is equal to s over s square plus 4. Say this is equation number 2. Now we use the initial condition that are given, that is equal to y of 0 and y prime of 0 both are equal to 0. When you substitute these conditions in equation number 2, you get s square capital Y of s minus s into 0 minus 0 plus capital Y of s is equal to 3s over s square plus 4. Now collect the common terms. In this way we get s square plus 1 into capital Y of s is equal to 3s over s square plus 4. Now I divide this s square plus 1 towards right side. This is equal to capital Y of s is equal to 3s over s square plus 1 into s square plus 4. This is our equation number 3. Now I take this equation, let 3s over s square plus 4 into s square plus 4 is equal to as plus b over s square plus 1 plus cs plus d over s square plus 4. This is equation number 4, and I write this equation number 4 in this style: 3s a s plus b into s square plus 4 plus cs plus d into s square plus 1. Now I multiply these two terms, the multiplying terms, and write it as as cube plus bs square plus 4as plus 4b plus cs cube plus ds square plus cs plus d, and collect the common terms. In this way I get 3s is equal to a plus c into s cube plus b plus d into s square plus 4a plus c into s plus 4b plus d. Now equating both sides, or we say equating the coefficients on both sides, so we get a plus c is equal to 0, b plus d is equal to 0, 4a plus c is equal to 3, 4b plus d is equal to 0. From equation number 1 I write a is equal to minus c in equation number 3. When I substitute this, I get c is equal to 4 into minus c plus c is equal to 3 minus 3c is equal to 3. In this way c is equal to minus 1. If I substitute this value of c is equal to minus 1 in equation number 3, I get in this equation a is equal to 1. So in this way we get two values of the constant c and a. When I take b is equal to minus d from equation number 4, when I put b is equal to minus d, I take this value from equation number 2, b is equal to minus d and substitute it in equation number 4. I get 4b plus d is equal to 0. Here I substitute the value of b, that is minus d plus d is equal to 0. Minus 3d is equal to 0. So d is equal to 0. When d is equal to 0, it means b is also equal to 0. Now I substitute all the values of the unknowns in equation number 4. I get 3s over s square plus 1 into s square plus 4 is equal to 1 into s plus 0 over s square plus 1 plus minus 1 into s plus 0 over s square plus 4. After simplification, I am writing it as s over s square plus 1 minus s over s square plus 4. So this is equation number v. So the last step is that we have to take the inverse Laplace transformation of equation number equation number v. So I am applying on each term the Laplace inverse. So I get y of t is equal to, and you know that what is the formula of this? It is the formula of cos of t, and this is the formula of cos 2t. Okay, in this way, this is our answer of this required example. In this way, I hope you understand this, and this is not a difficult task. You easily complete this such type of questions. Here in this lecture we solve how we can solve the differential equations. In our next lecture we will see how we can solve our system of differential equations. So inshallah we will meet in our next lecture. Till then, take care. Allah Hafiz.